Hi, so this is going to be the last video for the series competitive machine learning, at least for maybe 2023. So before we get into the super story, some drum rolls to get you excited. Let's go.
Come on down, Inyola. So I have to say this submission was absolutely mind-blowing. It involved creating new features using biological knowledge and adding those to the embeddings that we'd provided. It displays everything we love at InstaDeep: biological knowledge, machine learning expertise, technical excellence. Congratulations. In third place, we have Enigma, aka Paul Okewunmi. Please come on down. This was a really incredible submission with some extremely advanced deep learning skills on display. It involved fine-tuning the nucleotide transformer for 2,000 steps and then adding those embeddings to the embeddings we provided. So once again, really impressive display of deep learning expertise.
You just hold on by the side of the stage. We'll take a group picture with our top two who are present.
Now, ladies and gentlemen, the winner for this year's Bluechip Summit Employee
Let me help him. That's why we're
Is my
co-host.
AI doing me somehow?
No, he's from Ondo State. That's why.
All right, the Employee Attrition Prediction Competition, and this gentleman will be walking away with not 250, not 500, but
A
combined
submission of both. 750,000 naira, courtesy Bluechip Technologies Limited.
Ladies and gentlemen, a serial winner when it comes to AI competitions. This guy is always winning every single competition. Please make some noise for the future of AI in the person of Eniola Olaleye.
Congratulations to you.
Congratulations. Make some noise, people. Make some noise like it's your family member now. There we go.
Make some noise like he'll share the money with you.
No, don't say that. Congratulations. May you also
Now,
win.
can we have some?
Who's the first runner-up?
The first runner-up is drum rolls, goes home with 500,000 naira. Sahid Ayoni, congratulations. He's now 500,000 naira richer. 500,000 naira richer. Congratulations, Sahid Ayoni. On behalf of Bluechip Technologies Limited, we're presenting you 500,000
Smile, Said, smile.
naira.
Wait, hold on. Smile now, Said. It's 500K something. There we go.
He's currently developing some other algorithms in his head and predictions, so he's so busy. Congratulations to you.
So that was done for you to feel the energy, to get you pumped for the session. So just some drum rolls of the last competition that was won this past month. Then I'm just going to be walking you through the competition overview before we dive into the solution proper. So for the second competition, because we are going to be walking you through two competitions, the first one is the Bluechip Summit, which was done, and the second one was in Deep Learning Indaba. For Deep Learning Indaba, I'm going to be having a guest, which is Paul Okewunmi. Paul Okewunmi took third place in the particular challenge, so he's going to be walking us through the in-depth solution of his work. Then I'm just going to be going through the basic idea of my Bluechip challenge, how I was able to achieve top place. So let's just quickly dive into the Bluechip Summit. So for Bluechip Summit, the task we were given was employee attrition prediction. And attrition simply means we want to know which employee is going to leave a particular company. So we were given some attribute, and with machine learning, we were told to solve the challenge and see with the attributes we were given which particular employee is going to stay or which particular employee is going to leave. Then let me just move to the cassava, the one we did at Deep Learning Indaba, which is unveiling cassava secrets. So what we're tasked to do here is to be able to see with machine learning if a particular enhancer will spill over a particular region. So I'll just use fertilizer as an example. So let's say you pour fertilizer in a particular region, you want to see if it will spill to another region you don't want it to be. So we're tasked to use machine learning to see if an enhancer will be spilled over in a particular region. So firstly, I'm going to run you through how I approach any competition before we move into the detailed approach of this competition that was won. So there's this thing I took from Dr. Bayo. For people that have been into the data science space for long, you know Dr. Bayo is the founder of Data Science Nigeria. So Dr. Bayo will always say, try and understand the domain knowledge of the problem you want to solve. So for example, if you are given a task to solve with data science and the task is, let's say in the field of medicine, a particular subdomain. I'm not a doctor, so I have to go in depth a bit and try and understand the problem I'm actually about to solve. So for example, the first problem we're going to be looking at is attrition. I don't work as a banker, or I know nothing about attrition. So what I want to do is I want to understand attrition as it relates to the banking industry, or attrition as it relates to the kind of problem I want to solve. So that's key, and that's the first thing we need to do. So I'll share my screen and show you the detailed approach to how you can improve your model. So the first of all, you can try to improve your performance with data. So this is a particular post I wrote in 2019. It is still valid now, trust me. The first one is improving performance with your data. So when I say improve performance with your data, there are a lot of things you can do with your data, and the most crucial one that works every time is feature engineering. So you have a set of columns, you create new columns based on the set of column you have been given. Then also, if it is possible, you can add more data, but this most time is not always possible because you are limited to the data you are given in a particular competition. Then the second one, you can improve performance with algorithms. So your model algorithms and different kind of algorithms. You can also tune algorithms. So you can decide to use the initial parameters or work your way by tuning the parameters and getting the most optimized parameter for your particular solution. Then the fourth one is ensembles. So ensembles works every time for me. Just build different subset of model that learn different thing in my data, and I just merge them together and I see the accuracy of the model or the type of metric I'm using. I just see it improve steadily. I'm going to be going through the first solution we are going to be talking about. So without much ado, I'll just share my screen ASAP. So for the first solution, what we were tasked to do is to build a basic attrition model. So attrition, like we discussed earlier, is to know when a particular employee is going to leave a company. So for this solution, I built two models, and I'm going to be walking you through the two models. So for the first model, there was one thing that stood out, and after I saw that particular feature, I was like, this one, it seems we are going to take it home. So I'm just going to be going straight to it. So what stood out for me is the target encoding. So we were given a lot of categorical features. Let me count them. I think they're about 1, 2, 3. We had about 7 categorical features, and what stood out in this particular model for me was the target encoding. So I'll just explain the idea of the target encoding here. So normally the typical approach for categorical feature will be either you label and encode it, or you create a dummy variable for them. But target encoding is quite different because we are going to be using the targets that we are focused on here. So for example, if you look at the business travel here, the business travel is a particular categorical feature. So if we want to target and code it, we are going to use the target column, which is attrition here. So what the target encoding just does is it's categorize them based on the weight of the target. So simply using a group by based on that categorical variable, which is business travel, then your target column, which is attrition. So we are taking the mean and we sort the value. So looking at the result, we see non-travel is first, travel rarely is second, then travel frequently is third. So based on this weights, we are going to be giving them a number. So when we order them, we'll now have non-travel as 0, travel rarely as 1, and travel frequently as 2. If you are going to be using a label encoder, it can simply arrange it in a different way. So giving it this weight will give this model an ability to learn from this, that people that travel frequently have more weight than people that travel rarely and people that don't travel at all. Then I did it for other categorical features as well. First model, there was one thing that stood out, and after I saw that particular feature, I was like, this one, it seems we are going to take it home. So I'm just going to be going straight to it. So what stood out for me is the target encoding. So we were given a lot of categorical features. Let me count them. I think they're about 1, 2, 3. We had about 7 categorical features, and what stood out in this particular model for me was the target encoding. So I'll just explain the idea of the target encoding here. So normally the typical approach for categorical feature will be either you label encode it or you create a dummy variable for them. But target encoding is quite different because we are going to be using the targets that we are focused on here. So for example, if you look at the business travel here, the business travel is a particular categorical feature. So if we want to target encode it, we are going to use the target column, which is attrition here. So what the target encoding just does is it's categorize them based on the weight of the target. So simply using a group by based on that categorical variable, which is business travel, then your target column, which is attrition. So we are taking the mean and we sort the value. So looking at the result, we see non-travel is first, travel rarely is second, then travel frequently is third. So based on this weights, we are going to be giving them a number. So when we order them, we'll now have non-travel as 0, travel rarely as 1, and travel frequently as 2. If you are going to be using a label encoder, it can simply arrange it in a different way. So giving it this weight will give this model an ability to learn from this, that people that travel frequently have more weight than people that travel rarely and people that don't travel at all. Then I did it for other categorical features as well. So this is the function that I use to build this particular target encoding feature. So we can see that I did it for other columns as well. But let's just take a look at for department. So for department, when I did the target encoding as well, so we see research. So we see research and development appearing first, sales second, then human resources third. So this will order them orderly, like with the weight of the target column. So here we have research and development as first, we have sales as second, and we have human resources as third. So this is the order we are going to be getting in the column. So now let's check the columns after we have created the target encoding and see the results. So we are going to see that everything is ordered based on the target column. So we see the gender ordered, we see job role ordered, we see department ordered, we see overtime ordered. And I noticed that this particular feature were key to actually giving me a very good result on the leaderboard. Then after that, let's quickly move to the let's look at the feature importance and see. So we can see that overtime ordered was one of the variables that stood out in making this model actually perform very well. Let's look at the second model and see what stood out. So for this particular model, I created a lot of variables, like different kind of variable, a lot. So I could not really tell the key to this particular model performing well. But what I knew is that a lot of this feature actually did well. And another thing that stood out for this particular script was the modeling. So what I did for the modeling part was I decided to ensemble different models together. So after the creation of the all features and everything, you can select the number of models you want to choose to assemble at the end. So if you put 2 here, that means you're going to be assembling 2 different models based on the performance. If you put 5, you're going to be assembling 5 different models based on the performance that is shown here. So I'm going to be sharing the code after the whole discussion, and you can just go and play with it and get a overview and feel of the whole script yourself. But what I will say now is this was actually defining moment for me participating in this competition. This target encoding was just what did it for me. So you can maybe try it out in your next competition or next modeling approach. Yeah. I'm already in the house. Paul came third place in the just concluded Indaba competition, which was hosted by InstaDeep. So I'll just give it to Paul to give us a bit of introduction about himself and tell us just how he approached the challenge, and he will do a technical run through on his code as well. Yeah, Paul, over to you.
Yeah, so thanks, Annie. So yeah, I'm going to just talk about everything that led up to the competition and how the competition experience was for me. So before I start, I'll just quick introduction about myself. I'm Paul Okewunmi. I happen to be the community lead for DSN OAU. I also like I also happen to be working as a software engineering fellow with Meta via the MLH fellowship. So for me, the competition it was one I know I wanted to participate in, but before the competition, there was little to no detail about what the challenge was going to be about. And if if you know InstaDeep very well, you know InstaDeep's competitions are really not the easy ones.
Yeah,
And
molecular.
they used to be like this uniqueness about their
Mm-hmm.
competitions and all. So so for me personally, like there was little preparation because I really didn't know what to expect. But one thing I knew I wanted to do was, since we're going to be participating and the organizers are going to be there physically, I'll try to ask them as much question as I can. So since they're the domain experts and I know little or no knowledge about, I have little or no knowledge about
Protein.
nucleotides,
Mm-hmm.
DNA sequence, and also that was what I planned. That was what I did. And yeah, that was what I did. And I think that worked for me
Yeah,
pretty
it
well.
paid off.
And
Mm-hmm.
yeah, it paid off. Yeah. Um I paid very close attention when at the event when the competition was announced. I tried to wrap my head around what we're supposed to do. Eniola may have hinted about, I mean, I've given details about what the competition was about. So, but very quickly, I'll just talk about what it was about. So, um, the commission was about predicting um, if a DNA sequence had an overlap, if some region of a DNA sequence has an overlap of over 50% with an enhancer region.
Mm-hmm.
So enhancers are known. So from the information given about the competition, enhancers are some things that help you to produce some particular type of protein. So for a cassava plant, if you can find out the enhancer, you can try to produce more kind of the needed nutrients or the needed kind of proteins that will make the cassava more resilient to, it could be drought, it could be pests. So like if you can get just maximize use of the enhancers, you could make breakthroughs with cassava genomes and all. So yeah, that was the point line of everything we wanted to do. And it was a classification task. So you want to predict if the middle 200 region of it overlaps with an enhancer by over 50% or not. Okay, so the competition just gave us very limited information. So we had the sequence, the region where the sequence was gotten from. So given like a long DNA sequence, we're chunked into 100, a length of 100, and we're given the chromosome. So I think cassava has about 18 chromosomes, and you were given what chromosome the sequence fall in. And I think that was it. And you are now giving your targets. So because of the fact that you had limited data, we needed to find ways to make the most use of the data. So everybody was limited. You just needed to find something that would maximize the use of your data sets.
Sure.
One thing you can do is try to manually create features. You given that it's a sequence of A, C, G, and T, I guess,
Yes,
you can,
agency.
yeah, you can do something like, okay, count the number of A's, count the number of G's,
Mhm.
number of T's, but there's a limit to the manual features that you can create. So for me, I felt instead of manually creating features, why not find a pre-trained model or something that can act as a feature extractor that would give us some features or say embeddings. We
Mm.
combine we combine the embeddings with what was there's also embeddings gotten from AgroNT. AgroNT is InstaDeep's nucleotide transformer. It hasn't been released yet, but the so we're able to get very good accuracies by just using those embeddings. So if we can find if we can somehow get features gotten from say another transformer, you can combine them together with the
Mm-hmm.
embeddings that you already given, and you can use that as your training set. So that was the whole idea of what I did. And um I was feeling also that embeddings gotten from like a pre-trained model would probably be better than manually creating features.
Sure.
So yeah, so like one has to just make the maximum use of whatever you're given. So
Yeah.
like I said, I was always talking to the organizers. Shout out to one person in particular, Kevin. I
Okay.
can't remember his last name. So Kevin was very, very helpful. He was the one that suggested checking Hugging Face for
Pre-trained
InstaDeep's
model.
retrain models. Yeah,
Okay.
so I went to InstaDeep's Hugging Face
Reposition.
page. I saw like they had some nucleotide transformers that were trained on different species.
Mm.
It wasn't trained on cassava genomes, but the idea is that okay, since it's also trained on some type of genome,
Mm-hmm. It
then
should.
it could learn, yeah, it could
It
learn
could
like,
learn. Sure, sure.
yeah, it could just learn basic stuff and all. So that was the idea. I took that, I
And
fine-tuned it.
implemented it. Mm-hmm.
Yeah, I fine-tuned it to give me about it. So after fine-tuning, I was getting about accuracy of say 70%. After fine-tuning up to that point, I used that to extract embeddings, and I combined those embeddings with the ones InstaDeep gave us from their AgroNT model,
Mm.
and I trained with that.
Oh,
So yeah, very quickly, I'll just like do a walkthrough of what that looks like.
yeah, that would be
Uh,
beautiful.
Let me share. Okay, so we can confirm that you can see my screen.
Yes, I can see your screen.
Okay, so this is just the link of the convention will be dropped in the description, so you can
Yeah.
go ahead and check out everything you need to know about it. So this is the page where I was able to get um, InstaDeep's nucleotide transformer, and we check their different sizes. Let me just go back a little bit and zoom in. So if we check their different sizes, there's one that has 2.3 billion parameters. There's one that
That's
has
a lot.
500 million parameters. So like this was like the smallest one. So This was the one I was able to find too. So going to the code, this is just your basic installation, installing everything needed for my. I don't know if I should zoom in or it is just
Yeah, it's
fine.
clear. It's clear. It's fine.
Okay, so this is installing everything you need for the to run the notebook. Then Instadi made it very easy for us to download the data set. So this is everything you need to get your data set and all. So the data set was given in CSV format.
Mm,
Uh, this is basic important. And for me to be able to have reproducible results, I made sure to set seed because I was scared that I won't be able to reproduce my solution,
mm,
and the competition will need you to reproduce it in order for you to like justify your position.
sure.
So yeah, it just makes more sense to do that. So this function does everything for you. Um, since we'll be using GPUs, this PyTorch, you need to specify the device you'll be working on. So this is just specifying that you'll be using a GPU.
Mm-hmm.
And this is now where you load the pre-trained model. So if you look at this, um, this is um, this is loading the model from Hugging Face, and is also putting is adding a edge is adding a classification layer to the top. So when you use this now, you can, since I specified the number of labels, I can do a classification task. I can fine tune this on a classification task. And since that was what our data set we're supposed to do. So this is just loading the model straight from Hugging Face. If you're using the model from Hugging Face, you also need to, if you're pre-training the model, then you need to also use the exact tokenizer that was used.
Okay.
So yeah, so if you go to the if you go to the page, you see example code on how to use the tokenizer, how to load the model. So this was just basically what I did.
Mm,
Use the exact tokenizer so that you can have it just makes more sense. This is loading the train and test file, but one thing that also like helped in this competition was the way you split your training sets. So because I talked about like having 18 chromosomes for cassava.
okay.
In the training set, you had 12 out of the 18,
Mm,
and in the test set, you had 6 out of the 18, meaning there's no way you're not training on you've not seen the kind of you've not
cassava
seen
exists.
yeah, exactly. You've not seen the cassava in your training set at all.
Yeah.
So you need to train a model that can generalize over like different.
True. 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 So how did you undo that?
Yeah, so we are splitting on chromosomes. So
Okay.
since you have 12 chromosomes in your training set, you're taking eight. So you're splitting. You're using 8 out of it for training, using 4 out of it for testing, so that there's no like overlap. There's no data leak or no.
That's beautiful. Nice.
Okay, so yeah, so let me just. This is preparing for fine tuning the model. This
Mm-hmm.
is getting the sequence, getting the target, validation, and the validation labels. This is the test where we are supposed to predict and submit. This is everything regarding preparation, tokenization,
Mm,
and yeah. So like Hugging Face transformers make it easy for you to like do these things, because imagine writing all this from scratch. It will be quite difficult. This
mm.
is tokenizing the training tests and validation sets. Then
I'm
this is
Organ Face
setting.
directly, right?
Yeah, yes. So
Okay.
this is setting the parameters for your training. So you see that I used a very small batch size because like the model, even if the model is the smallest of them, which the smallest of them even has 500 million parameters. So given that there's limited constraint of using Google Colab, there's little you can do. So you're batching your data is being passed in very in small batches so that you don't exhaust your
You're
GPU
okay.
use your
Mm-hmm.
GPU memory. Yeah. So using batch size of 4, um, I used the same learning rate that was used in training the nuclear transformer. Um, then I'm training for 200 steps. I'm sorry, 2000 steps. So training for 2000 steps and seeing what the result is going to look like.
Your
This is just,
AirPods. Your
yeah,
AirPods
so it's,
two.
yeah, we are training for those 2000 steps. It's just like training for X epochs, but in this case, it is steps.
Okay, okay.
We are making sure that we are our metrics for the best model is accuracy. So while it's training, I'm going to be getting the accuracy score
Mm-hmm.
as it trains. This is just a function to help calculate accuracy, and this is where we do the train. This is where we declare the trainer and passing in the tokenized data, um, the model, and the metrics that you want to compute. And this
Mm.
is where the training is done. So I stated here that this takes quite a long time.
Wow.
So yeah, so like once you do this once, you just need to um extract the embeddings and store it somewhere so that you don't have to do this again.
Again, okay.
So yeah, you see like um the accuracy score as it keeps fluctuating, but
Mm-hmm.
at some point you get something close to 70. So this is 769, 69, 69. At this point, I was also like, okay, this model has learned it has learned
Pretty
quite
much, yeah.
a lot
Mm-hmm.
already from the sequences we're given.
Mm-hmm.
Then this is storing the model. You don't have to store it, but because I was always exhausting the GPU,
Yeah.
I had to store it, reload it, use it to extract embeddings.
Mm-hmm.
So this is the model being loaded again, and this is now a function that helps you to extract embeddings. So the thing is, you have a model, and you have the sequence. The sequence is passed into the model. The model gives you a numerical representation of what the sequence is.
Okay.
So that's what we call embedding. So this was now used I now extracted embeddings for all the cassava, the sequence that were given.
Okay.
This is doing it for computing the embeddings for the training sets, computing the embeddings for the test sets,
Mm.
and storing it as a um, as a NumPy object. Yeah, like storing the array as .npy so that
Mm-hmm.
I can always load it again and I don't have to train and recompute the embeddings. So I should state that the output embeddings gotten from this is about 1,280. That's 1280, the length or the size, if you may call it that way.
Mm.
And the length of the embeddings that was gotten from AgroNT, the one
The trend.
base, yeah, provided was
Mm-hmm.
1,500. So if
Oh,
you
so,
combine 1,000, an embedding of length 1,500 plus 1,280, you have about, I think, 3,780, if I'm correct. Yeah,
one.
2,780. So that was what I was now going to be training with.
Wow.
So this is just me combining those
Embedding.
embeddings with our training embeddings. And so I talked about manually creating features. I felt okay, I need every feature I can get. So I
Mm-hmm.
still went there to create some features. Yeah, so this is a function that just helps you to handle that.
So you
Um
still you use this also?
yes, this adds like this adds four features,
Yeah.
yeah, four columns,
Because
four
I had
features to
this
it.
also in my own.
Yeah, so I felt like okay, every feature we can get, just pass
Mm-hmm.
it into it,
Mm-hmm.
they'll see what can come out of it. Okay, so this is where I start the combined data, which is AgroNT's embeddings plus our own embeddings and the manual feature I created. So all combined, you have about 2,000 and 3,784
Wow.
size. So then after doing that, then I now trained like you train a regular machine learning model. So what I did was I trained three um, very good models using boosting trees. So I trained XGBoost, hard boost and LGBM on this combined embeddings.
Mm.
So another thing I think worked for me was train when you're training for say 5 folds or X number of folds,
Mm.
you want to use a different combination of. So since I said we are splitting on chromosomes, you want unique chromosomes every time every iteration you make. So for the first fold, you want a different set of chromosomes for
Yeah.
test, and the next fold you want a different set of chromosomes for train and test. So like
To generalize, yeah.
yes, exactly. So one thing I did was to change the random states at every iteration
Oh,
so that
nice.
you can have a different set of
Pose.
chromosomes for train and test every time. So I did that I can't show the output because like it takes time to
Time
run
to
this.
run, yeah, yeah, that's fine.
So I did this is training for XGBoost. This is training for card boost with different parameters. The same thing I did. I'm changing random state at every iteration. And then this is training for LGBM. And yeah, finally combining the three. So since I was training for 5 folds,
Mm-hmm.
so meaning you have predictions for each fold. For
Yeah.
LGBM, you're going to have 5 predictions. For card boost, 5 for for XG boost, 5. So combining those 5, you have 15.
Mm.
So you have 15 different predictions. They're now taking like a vote. So this is what it looks like. So different folds have given you different predictions. Then you just take the most frequently occurring or say the mode. So meaning if 10 of the models are telling you one and 5 are telling you zero, you probably want to go with one. So
Mm-hmm.
that was what I did. Yeah, just to get a submission. So to select my best submissions, I selected the best individual model. So the one that gave me the best cross-validation score for one model. Then I selected the ensemble of the 3 models. So this is like combining all 15-fold predictions. And yeah, stacking them together to just give you one one file. And that was what I submitted.
Oh, nice, nice.
So yeah, like summary of everything, get a pre-trained nucleotide transformer, fine-tune it, use it to extract embeddings, combine these embeddings with the one you were given, train your regular models,
Mm-hmm.
and yeah, so at the end of the competition, you try to find ways of increasing your score by finding ways to ensemble all your predictions and
Mm-hmm.
stuff like that.
Mm-hmm.
That was
Mm-hmm.
why I did all this.
What was your
So yeah,
accuracy on the leaderboard again? 70 what?
so is it like for the was it for
For the
private?
private leaderboard, yeah, 70 what?
Yeah, so private, I can't remember. I think 74.28.
74,281. Okay,
Yes.
mine was 75, 75.
Yeah, you were like,
My solution was actually
yeah,
pretty simpler than what you did. Like you had like a lot of features. Imagine I had
yes.
some of those features and I'm having
Like
75%.
I also felt like that was why I was surprised the fact that you didn't do too much, or but you just like made use of the little you
Exactly like
were
the
come
bendings
up.
they gave and just did some a
Yes,
bit of
yes.
feature
So
engineering.
another thing I
Single
feel
model,
was
no no stacking again, just cat boost
yeah.
and that was it.
I think another thing that would have helped was so since I think I discussed with you and you talked about like predicting probabilities, then combining those
Mhm.
probabilities.
Yeah.
Yeah, so I feel like it's one thing I could have tried was if given that I was just predicting zeros or ones, I could
Mhm.
predict probabilities, and instead of combining the zeros and ones for all the 15-fold predictions, I could just take the mean of the probabilities, and probably that would help. But I really haven't had time to like experiment again and see
Yeah,
how to.
time factor. We also consider time factor. That's
Yeah,
why.
we're
So
very
initially,
constrained.
initially for me, I was just using their old starter notebook, but I saw that idea was not coming, so I just decided to go
Yeah.
from scratch and
Yeah, and there was little time because
yeah, just be
and
creative.
other activities
Just
were going on.
you get.
Yeah, so like
Yeah, so beautiful work, beautiful work. Thank you for the.
yeah.
I'm actually surprised seeing like the embed. I thought like
Mm,
okay maybe just
yeah, I think someone else did this
okay.
embedding thing, but he used a different model. He trained using fast AI,
Uh,
so that was easier to train. And he also did um he also predicted probabilities and worked with probabilities instead of predicting outright zeros or ones.
okay.
That's I think he had also a very good score.
Mm.
So yeah, that's my solution.
Yeah.
It
So
seemed like an over, but yeah, it's what it is.
yeah. As long we won the prize, yeah. So it's
Yeah,
definitely worth it. Like you did a lot. And kudos to you, man. Well
yeah,
done. Well done.
yeah. Thanks.
Yeah, so that is it, and that is Paul Okewunmi going through a solution for us. Thank you.
Yeah.
Yeah.
So I'll stop sharing.
Mhm.
So thanks for having me, Maniela.
Welcome. So the link to the code will be shared in the description, and you guys can have a look
Okay.
at it. Yeah.